Hi everyone. In today's session, we will be solving few previous year problems on integral calculus from GATE and engineering services examinations. So let's begin. First question is the expression V is equal to for the volume of a cone is equal to. Okay. So let us assume 1 minus small h by capital H is equal to T. Now differentiate with respect to small h. We have 0 minus dH by capital H is equal to dt. So minus dH is equal to capital H dt. Okay, now let us put this back to the original integral. So we have pi r square, and yes, limit C, small h is varying from 0 to capital H. So when small h is 0, so t is 1. And when small h is equal to capital H, t is equal to 1 minus 1, that is 0. So t is varying from 0 to 1. Okay, 0 to 1, and t square, and also d, in place of dh we have minus capital H dt, right? Since pi r square h is a constant, we can take pi r square h out and integrate t square dt from 0 to 1. So we will get 1 by 3 pi r square h. And we know that the volume of a cone is equal to 1 by 3 pi r square h. Yes. Now we will consider option A and option D because these contains variable r. Okay, as variable of integration is r here in option A and D, so we will consider A and D only. So let us check first option A. So while integrating with respect to small r, this all will become constant. So for the option A, we will have pi r cube 1 minus small h by capital H whole square as the answer. Okay. So now let us check the option D. So option D is, so this is constant, and 0 to r 1 minus r by capital R whole square dr. Okay, so this option D can be rewritten as, okay. Now let us put 1 minus small r by capital R as t. So you will get minus dr by capital R as dt, which gives minus dr is equal to capital R times dt. Now let us integrate 4 pi h. Okay, now when r was varying from 0 to r, so t will be varying from, okay, so if small r is capital R, then this is 0. So when small r is equal to capital R, t is equal to 0. And when small r is equal to 0, t will be equal to 1. So t is varying from 0 to 1, right? Now okay, here one r is also there. So this is t square 1 minus r small r by capital R whole square is t square, and small r can be written as 1 minus t, okay, 1 minus t, see, capital R. So now r 1 minus t and t square as this is t square, so t square and minus r dt. Now capital R is a constant, so we have 4 pi r square h 0 to 1 t square minus t cube, agree, okay, dt. So now four pi r square h, so by integrating we have t cube by cube minus t4 by 4 and 0 to 1. This will be equal to 4 pi r square h and 1 by 12. 1 by 12, which is equal to 1 by 3 pi r square h. So which is equal to the volume of a cone. So D is the right answer. Okay. Let us go to the next problem. A surface is integrated once over a path consisting of the points that satisfy x plus 1 whole square plus y minus 1 whole square is equal to root 2. This is nothing but a equation of a circle with center minus 1 comma 1 and radius as root 2, right? So okay, so parametric equation of path along the surface is x plus 1 is equal to root 2 cos theta, since root 2 is the radius, and y minus 1 is equal to root 2 sin theta. Yes, so x can be written as root 2 cos theta minus 1 and y is equal to root 2 sin theta plus 1. Now let us put the values of x and y in the equation of the surface. So we have 2 root 2 cos theta 2x minus 1 and plus 5y, so plus 5 root 2 sin theta plus 1 minus 3. Okay, so now see, theta is varying from, since the path is a circle, so theta is varying from 0 to 2 pi, 0 to 2 pi d theta, right? Now 0 to 2 pi 2 root 2 cos theta minus 2 plus 5 root 2 sin theta plus 5 minus 3 d theta. Now let us evaluate. So we will have, so this is plus 5 minus 5 0, so we have 2 root 2 cos theta plus 5 root 2 sin theta d theta 0 to 2 pi. Again 2 root 2 integration of cos theta is sin theta 0 to 2 pi plus 5 root 2 minus cos theta and 0 to 2 pi. Right? and this will be equal to 2 root 2 sine 2 pi minus sine 0, which is 0 minus 0. So 2 root 2 0 minus 0, and if you take this minus out, so 5 root 2 cos 2 pi is 1 and cos 0 is again 1. So this is 0, right? So now answer is D. Okay. Now let us go to the next problem. The volume of an object expressed in spherical coordinates is given by V is equal to the value of the integral is. See, this is given in a spherical coordinate. So, and also the limits are constant. Notice that the limits are constant. So for constant limits, it hardly matters whether you first integrate with respect to r or theta or phi. Okay. So now 0 to 2 pi, 0 to pi by 3. So let us first integrate this with respect to r. Okay. And since this is a limit for r, this can be a limit of phi and this could be theta. See, spherical coordinate system consists of three quantities: rho, theta and phi. So if this is x, this is y and this is z. Okay. So say this is rho, theta and phi. So rho is the distance from the origin to the point, and we require rho should be greater than or equal to 0. Next, there is theta. This is the angle between the positive x-axis and the line. If you drop a perpendicular on xy plane and join this, then this is r, and so this angle is theta, right? Now finally there is phi. So this is the angle between positive z axis and the line from the origin to the point, means this. So obviously theta varies from 0 to 2 pi, and phi varies from 0 to pi. So hence this is phi and this is theta. Okay. So now let us evaluate the integral. Zero to 2 pi, 0 to pi by 3. Let us first integrate r square with respect to r, which will be r cube by 3, and limits are 0 to 1, then sin phi, d phi and then d theta. So this is 1 by 3, right? So take 1 by 3 out. So now 0 to 2 pi, and now we have sin phi d phi, whose integration is minus cos phi. So minus cos phi, integrate from 0 to pi by 3, and then d theta. Now we have minus cos pi by 3, which is cos 60, and which is 1 by 2, and minus cos 0, which is, so first minus 1 by 2 plus cos 0, which is 1, so which is again plus 1 by 2, so you can take this 1 by 2 out. So 1 by 3 into 1 by 2, so we are left with 0 to 2 pi d theta. Now this is equal to 1 by 3 into 1 by 2 into 2 pi minus 0, so which is pi by 3. Okay, so pi by 3 is the right answer. Okay, now let us go to the next problem. The value of the integral 0 to infinity and 0 to infinity e power minus x square e power minus y square dx dy. So here e power minus x square is given in the integral, so gamma function can be used to solve this. Yes. So let us first evaluate 0 to infinity. So this can be written as, see, so since the limits are constant, so this can be written as 0 to infinity e power minus x square dx and 0 to infinity e power minus y square dy, right? Okay. So now let us put x square is equal to t. So which will be equal to 2x dx is equal to dt, which dx is equal to dt by 2x. Yes. So now let us replace x square by t. So we have e power minus t and dt by 2x. So let us take 1 by 2 out, and 1 by x can be written as t power minus 1 by 2 to t power minus 1 by 2 dt and 0 to infinity e power minus y square dy. Okay, so we can write this as 1 by 2. Yes, if x is varying from 0 to infinity, so t will be also will be varying from 0 to infinity. So 1 by 2, 0 to infinity and 0 to infinity, so e power minus t, and minus 1 by 2 can be written as minus 1 plus 1 by 2 dt and then e power minus y square dy. Now recall that gamma n was written as 0 to infinity e power minus t and t power n minus 1 dt. Okay, so n is 1 by 2 here, so this is gamma 1 by 2. Okay, and we know that gamma 1 by 2 is equal to root under pi. So this can be rewritten as, so root pi by 2, root pi by 2, and similarly you will get 0 to infinity e power minus y square dy. If you will evaluate this, you will get root pi by 2. Okay, so we have root pi by 2 and 0 to infinity e power minus y square dy and if you evaluate this will come again as root pi by 2. So answer will be root pi by 2 into root pi by 2, which is pi by 4. Okay, so remember this. Right? Okay, so now answer is pi by 4. Alternatively, if you recall, one pi sigma root 2 pi e power minus x minus mu by sigma whole square and 1 by 2 . So this is a probability distribution function of a Gaussian random variable. Okay, so if you put mu is equal to mean as equal to 0 and sigma is standard deviation is equal to 1 by 2 sigma square as 1 by 2, and we know that minus infinity to infinity, if you integrate a probability distribution function from minus infinite to plus infinite, so you will get answer as 1, right? And if you integrate from 0 to infinity, you will get 1 by 2. Okay, now so 0 to infinity e power minus x square dx, you can write multiply and divide by sigma root 2 pi into sigma root 2 pi . Yes, 0 to infinite e power minus x square. So if you put mu is equal to 0 and sigma square is equal to 1 by 2 and dx. Okay, so we know that this will be equal to one by 2. So we have sigma as 1 by sigma square, sigma is 1 by 2 and sigma square as 1 by root 2 and root 2 pi, so into 1 by 2. So we have root pi by 2. Again, if we evaluate 0 to infinite e power minus y square dy, so which will be again equal to root pi by 2. So final answer will be root pi by 2 into root pi by 2, that is pi by 4. So this is a more easier way to solve. Okay, let us go to the next problem. The value of integral minus pi by 2 to pi by 2 x cos x dx is. So applying by parts integration. Okay, let us put this is u and this is v. So u integral v minus du integral v dx, right? So x, so integral cos x is sin x minus pi by 2 to pi by 2 minus, so dx by dx is 1, so 1 into sin x dx minus pi by 2 to pi by 2, so which is equal to pi by 2, and sin pi by 2 is 1, pi by 2 minus pi by 2 sin minus of pi by 2, and this is minus cos x minus pi by 2 to pi by 2. So cos pi by 2 is 0 and cos minus pi by 2 is also 0, so this is 0 and this is minus 1, so pi by 2 minus of pi by 2, this is 0, so 0 minus 0, so answer is 0. Okay. So second method is, so from properties we know that if fx is an odd function, then so if fx is let us say f of x is x cos x, and f of minus x we have minus x cos of minus x, which is minus x cos x. So that means fx is a odd function. So if it is a odd function, so minus pi by 2 but 2 pi by 2 is given as x cos x dx is equal to 0. Okay. So if you remember the properties, so you can directly apply the property here. So answer is 0. Okay. Now let us go to the next problem. Consider the shaded triangle region P shown in the figure. What is, okay, we need to evaluate this integral. Okay, so the equation of this line, this straight line, so with x-intercept as 2 and y-intercept as 1, so we can write x by 2 plus y by 1 is equal to 1. So y is equal to 1 minus x by 2. This gives x is equal to 2 minus 2y. Okay, let us consider horizontal strip. Right? So y is constant and x is varying from 0 to 1 end point lies on this straight line. So is varying from, x is varying from 0 to 2 minus 2y. See, 0 to 2 minus 2y, xy, dx and dy, and y is varying from 0 to 1. Okay, now integrate this xy with respect to x, keeping as y constant. So yx square by 2, 0 to 2 minus 2y, and dy 0 to 1. So you will have y by 2 and 2 minus 2y whole square dy 0 to 1. Again 2y minus 4 plus 4y square minus 8y, and if you multiply y by 2, so 4 by 2y, and this will be y cube two y cube, and this will be 4 y square. Okay, and if you integrate, so you will get 2y square by 2 plus 2y 4 by 4 minus 4y cube by 3, and you will have this as, so y square plus y raised to the power 4 by 2 minus 4y cube by 3, and 0 to 1. So this is 1 plus 1 by 2 minus 1 by 4 by 3, right? And this is nothing but 6 plus 3 minus 4 minus 8 by 6, which is 1 by 6. Okay, so answer is 1 by 6. Alternatively, we may also write this integral as, so first we took horizontal strip, now we can take vertical strip as well, and keeping x as constant. Okay, so in the vertical strip, x is a constant and y is varying from 0 to, so one end point lies on this straight line, which is 1 minus x by 2. So 1 minus x by 2, and x is varying from 0 to 2. Okay, so we may write 0 to 2 minus x by 2 and 0 to 2. So using vertical strip, this will also result in 1 by 6. Okay, you may try this on your own. So answer will be 1 by 6. Okay, let us go to the next problem. Zero to pi by 4, 1 minus tan a by 1 plus tan x dx evaluates 2. Right? So using property, if you remember, this is equal to 0 to a f of a minus x dx. Right? So this integral can be rewritten as 0 to pi by 4, 1 minus tan pi by 4 minus x, so a is pi by 4 here, by 1 plus tan pi by 4 minus x dx. So we now know that tan of a minus b is equal to tan a minus tan b by 1 plus tan a tan b. Yes. So now if we expand 1 minus tan pi by 4 minus tan x and 1 plus tan pi by 4 tan x. So this is tan pi by 4 is nothing but tan 45, and we have tan 45 as 1. Okay. So this is 1 minus tan x by 1 plus tan x. And this is also 1 minus tan x by 1 plus tan x. So this can be written as 1 minus tan x by 1 plus tan x. Again, in the denominator, 1 plus 1 minus tan x by 1 plus tan x dx and integral 0 to pi by 4. Right? So now if we evaluate, so we will have 1 plus tan x minus 1 minus tan x and 1 plus tan x plus 1 minus tan x. This will be plus. Again, this is 2 tan x by 2 dx and 0 to pi by 4. Okay, so 0 to pi by 4 tan x dx. And we know that integral tan x is log of secant x. So log of secant x 0 to pi by 4. So this is log secant pi by 4 minus log secant 0. Okay, so this is log root 2 minus log 1. So which is nothing but log 2 1 by 2 minus 0. So this can be written as 1 by 2 log 2. Okay, so this is the right answer. D is the right answer. Okay, let us go to the next problem. A path AB in the form of 1/4 of a circle of unit radius is shown in the figure. Integration of x plus y whole square on path AB transversed in a counterclockwise sense is. Here path AB is a quarter of a circle. So we can write x square plus y square is equal to 1. So this is a equation of a circle with radius 1 and origin as the center. So let us parameterize the path. So x is equal to r cos theta, r is 1, so cos theta, and y is equal to sin theta. And along path AB, theta varies from Theta varies from 0 to pi by 2. So we have path AB, so 0 to pi by 2, and x plus y whole square r d theta. Since we are considering xy plane in a two-dimensional plane, so r d theta. So we have 0 to pi by 2 cos theta plus sin theta whole square into r is 1, so 1 d theta. Okay, now expand sin square theta plus cos square theta plus 2 sin theta cos theta and d theta 0 to pi by 2. Okay, sin square theta plus cos square theta is 1 and 2 sin theta cos theta is sin 2 theta. So d theta. Okay. This is theta plus minus cos 2 theta by theta, 2 and 0 to pi by 2. Now again pi by 2 plus if you take minus out, so cos 2 pi by 2 minus cos 0. So this is pi by 2 minus 1 by 2 and this is 1 cos pi minus 1 and cos 0 is 1. So equal to pi by 2. So minus 2 cancel and plus 1. Right? So pi by 2 plus 1 is the right answer. Let us go to the next problem. Let I be equal to, then I may also be expressed as. Let us draw the graph. Okay. So this is 0. This is 0 comma 0. Okay, we have y is equal to 0 and y is equal to x square. So y is equal to x square would be somewhat like this. Okay. So this is y is equal to x square and x is varying from 0 to 1. So x is equal to 0 is this line, x is equal to 0, and y is equal to 0 is this line, and x is equal to 1 is this line. The intersection point is 1 comma 1. This is x is equal to 1. So we have drawn all the limits here in this graph. So here, since x is constant, so we are here they have considered vertical strip. So obviously by looking at the options we need to change the order of integration. So if this is a vertical strip, so see y is varying from 0 to x square. So y is varying from 0 to x square and x is varying from 0 to 1. Okay. If you move this slider like this, now in order to change the order of integration, we have to consider vertical strip. So vertical strip. So here y must be constant. So y is constant and y is varying from 0 to 1 and x is varying from, so x lies on this one end point lies on this line, this curve y is equal to x square. So x is equal to root under y and x is varying from root under y to 1. So this point lies on x is equal to 1 and y is varying from 0 to 1. So obviously answer is C. Right? Let us go to the next problem. A parabola x is equal to y square with x lying in between 0 and 1 is shown in the figure. The volume of the solid of rotation obtained by rotating the shaded area by 360 degree around the x-axis is. let me show you how this rotation is going to make the figure. So after rotation, okay, so this will look like somewhat like this. Okay, so we know that since the rotation is about x-axis, so volume will be equal to pi y square dx, and varying from 0 to 1, so limits are 0 and 1. And y square is nothing but x, so it is simply 0 to 1 pi x dx, which is equal to pi x square by 2, 0 to 1, which is nothing but pi by 2. Okay, so pi by 2 is the right answer. Yes. So we found out this volume of the solid of rotation. Okay, let us go to the next problem. The value of the following definite integral is, okay, so here this x and log x. So what we can do is, let us put x is equal to e raised to the power t, then dx will be equal to e raised to the power d dt. Yes, and when x is equal to 1, t is equal to 0, and when x is equal to e, t is equal to 1. Yes, so t is varying from 0 to 1, and let us replace x and log x, ln x. So 0 to 1 t, and ln x is nothing but e raised to the power t, and then dx is e raised to the power t dt. So that means we have 0 to 1 t e raised to the power 2t dt. Okay. Now this is in the u into v form. Okay. So t integral e raised to the power 2t dt minus integral dt by dt and integral e raised to the power 2t dt. Okay. So this is t e raised to the power 2t by 2 minus this is 1, so integral e raised to the power 2t by 2 dt, 0 to 1, 0 to 1. So again, so this is e raised to the power 2 by 2 minus 0, and minus for this, let us evaluate this. So this is e raised to the power 2t by 4, 0 to 1. So this is e square by 2 minus e square by 4. Okay, and minus, if you put 0, so this is 1 by 4 minus 1 by 4. So this will be e square by 2 minus e square by 4 plus 1 by 4. So which is equal to e squared plus 1 by 4. Okay. So if you calculate this using calculator, so you will have 2.097 as the answer. Right? Let us go to the next problem. The value of integral 0 to pi and y to pi, this is x, this is y, okay, equal to. So if you notice that this solving this integral is more easier if you change the order of integration. Okay, so x is varying from y to pi and y is varying from 0 to pi. So now this is nothing but horizontal strip where y is constant. So okay, so x is equal to y is this line, and say pi is this line, x is equal to pi. So if you here they considered horizontal strip. So x is varying from y to pi and y is varying from 0 to pi. Yes. So now changing the order of integration, we will have okay. So here x is constant. So x is varying from 0 to pi and y is varying from 0 to y is equal to x. So this is nothing but 0 to x and 0 to pi. Sin x by x dx, sin x by x dy and dx. Now let us evaluate this. So this integral will be equal to this integral. So evaluating this, so first we have to integrate sin x by x with respect to y, keeping x as constant. So this will be sin x by x into y. So 0 to x and 0 to pi dx. Okay, so this is nothing but sin x by x into x, so which is cancelled, and dx 0 to pi. Now we know the integration of sin x. This is minus cos x varying from 0 to pi. This is minus cos pi plus cos 0. So cos pi is minus 1. So this is plus 1 plus 1. So 2 is the right answer. Okay. Let us go to the next problem. The value of integral 0 to 2 pi 3 by 9 plus sine square theta d theta is. Okay. So here let us multiply and divide by cos theta. Okay. So cos square theta. So cos square theta by 9 by cos square theta plus sin square theta by cos square theta, that is tan square theta d theta 0 to 2 pi. Okay. So this is 0 to 2 pi sec 3 sec square theta by 9 sec square theta plus tan square theta d theta. Right? Now this can be rewritten as 0 to 4 into pi by 2 3 sec square theta by 9 sec square theta. Adding and subtracting 9 tan square theta. So minus 9 tan square theta plus 9 tan square theta and plus tan square theta. Why? Because we know that sec square theta minus tan square theta is 1. Now 4 can be taken outside. 0 to pi by 2 and 3 sec square theta. Okay, you can take 3 out. 4 into 3 sec square theta by 9 plus 10 tan square theta. 10 tan square theta. Okay. Now let us put, let us take 10 common here. So this will become 9 by 10. Now 4 into 3, that is 12. 12 by 10. 0 to pi by 2. Sec square theta by 9 by 10 plus tan square theta. Okay. So again, if we put tan theta as t, so sec square theta d theta will be equal to dt. And about the limits, theta is varying from 0 to pi by 2. So t will be equal to 0. And if theta is equal to pi by 2, then t is varying from 0 to, theta is pi by 2, then this is infinite, so infinite. So t is varying from 0 to infinite. So again 12 by 10, 0 to pi by 2. Okay, 0 to infinity, right? 0 to infinity dt by, so you can write as root under 9 by 10 square plus t square. Clear? Now, so we know that 1 by 1 plus t square, integration of 1 by 1 plus t square is equal to tan inverse t. Yes? And if this is a square plus t square, if it is dt by a square plus t square, then this is equal to 1 by a tan inverse x by a plus c. We know this. So now we have a standard form. So the answer is 12 by 10 and this is 3 by root 10. So a is 1 by 3 by root 10 tan inverse t by 3 by root 10, varying from 0 to infinity. Okay. So now if you calculate this, if you simplify this, so you will get 4 by root 10 and pi by 2. So answer is 2 pi by root under 10. Okay. So answer is A here. Right? Now let us go to the next problem. The values of integrals r. Okay. So let us solve first. Let us evaluate this integral. So if this is I1 and this is I2. Okay. So let us solve I1 first. So I1 is equal to 0 to 1, 0 to 1 x minus y, x plus y whole cube dy dx. So solving the inner integral first. Okay. Adding and subtracting x in the numerator, we have x minus y plus x minus x by x plus y whole cube dy 0 to 1. So you can write this as minus of x plus y and plus 2x. Okay, so 2x by x plus y whole cube dy 0 to 1 minus 1 by x plus y whole square dy. Now integrating this, we have two x plus y minus x plus y whole power minus 2 and minus 2, and integrating this you will get x plus y minus 1 by minus 1. Okay, so 0 to 1. Now simplify this. Okay, this is cancelled. So minus x by x plus y whole square minus plus 1 by x plus y. Okay, 0 to 1. Again simplify this. So x plus y whole square in the denominator, so minus x plus y. So you will have only plus y in the numerator. So this is y by x plus y whole square. Now you can put the limit. So this is 1 by x plus 1 whole square. Okay. So result of the inner integral is 1 by x plus 1 whole square. Now for outer integral with respect to x, integrate. So integrating this with respect to x dx 0 to 1. So this is minus 1 by x plus 1 and limit 0 to 1. So this now becomes minus half minus 1. So which is plus half. So 0.5. Similarly, solving while evaluating I2, integrate inner integral first and then outer integral. Okay, so you will get the answer as minus 0.5. Try this at home, try this on your own. Okay, so this will be the right answer, 0.5 and minus 0.5 respectively. Okay, so let us go to the next problem. The value of the integral is, okay, let us put x minus 1 as, say, z, then dx will be equal to dz. Now for x is equal to 0, z is minus 1. For x is equal to 0, z is minus 1, and x is equal to 2, z is 1. Okay, so now this reduces to minus 1 to 1 z square sin z square plus cos z. Okay, now this is, say this is fz. Let us find f of minus z. So this is z square sin of minus z. So sine is a odd function, so minus sin z by z square. This is z square plus cos of minus z is equal to cos of z, since cos is an even function. So now we can write f of minus z is equal to minus of f of z. That means function is odd. Okay. Then integration is 0. Okay. So 0 is the right answer. Now let us go to the next problem. 0 to 2 pi modulus of x sin x dx k pi, then value of k is equal to. Okay. So now let us separate this from 0 to pi x sin x dx. Okay. Since in 0 to pi sin x is positive, and from in the interval pi to 2 pi sin x is negative, so this will be equal to pi to 2 pi minus of x sin x dx, which is equal to k times pi. Evaluating, we have minus x cos x plus sin x 0 to pi plus minus of minus x cos x plus sin x pi to 2 pi. Yes, which is equal to k times pi. So if you evaluate this, you will get 4 times pi is equal to k times pi. So k is equal to 4. Okay. Okay, let us go to the next problem. To evaluate the double integral, we make the substitution u is equal to 2x minus y by 2 and v is equal to y by 2. The integral will reduce to. Okay. So we have 2x minus y by 2 as u and x minus y by 2. This will give x minus y by 2 as u. So dx will be equal to du, and at x is equal to y by 2, we have u as 0, y by 2 minus y by 2 0, and at x is equal to y by 2 plus 1, u is equal to y by 2 plus 1 minus of y by 2, that is 1. So now the integral becomes 0 to 1, u varies from 0 to 1, u du, right? and so dy 0 to 8. Okay. Now y is equal to v is equal to y by 2. So v is equal to y by 2. So dv is equal to dy by dy by 2. That means dy is equal to 2 times dv, and y is varying from 0 to 8. So if y is equal to 0, v is also 0, and if y is equal to 8, v is equal to 4. 8 by 2, 4. Okay. Now the integral becomes 0 to 1 u du and 0 to 4 times 2 dv, right? Okay, you have to find out this only. So answer is B. 0 to 4, 0 to 1, 2u, 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 du, dv, right? You can take this 2 inside. Okay. Right? Now let us go to the next problem. F x y is a continuous function defined over x y, so belongs to 0 and 1, 0 and 1, given the two constraints x is greater than y square and y is greater than x square. So let us find this intersection. Okay, so x is equal to y square is a parabola like this, and x square is equal to y is a parabola like this. So this is x square is equal to y, and this is y square is equal to x. Okay, and this is the area we need to find. So taking horizontal strip, okay, so y is constant and x is varying from the lower end lies on y square is equal to x. So x is equal to y square, and the second end lies on the x square is equal to y. So that means x is varying from y square to root under y. So x is varying from y square to root under y fxy, and y is varying from 0 to 1. Okay, so y is varying from 0 to 1. Okay, and of course dx dy. So this is the answer. A is the answer. Okay, let us go to the next problem. The value of cos 4 3 theta and sin cube 6 theta is. Okay, let 3 theta be equal to t. Okay. Now 3 times d theta is equal to dt. That means d theta is equal to dt by 3. Okay. Now theta is varying from 0 to pi by 6. So when theta is equal to 0, t is equal to also 0. And when theta is equal to pi by 6, t is pi by 2. Yes. So t is varying from 0 to pi by 2. Okay. Now integral simplifies to 0 to pi by 2 cos 4t into sin cube 2t and dt by 3. Okay. So you can take this 1 by 3 outside. 1 by 3. Now sin 2t is 2 sin t cos t. So cos 4t 2 sin, you can take 2 out, 0 to pi by 2, 2 by 3, sorry 2 cube by 3, and sin cube t cos cube t, sin cube t cos cube t and dt, right? So this is 8. Now this is cos 7 t and sin cube t dt, right? Now this has reduced to the form cos mt and sin nt dt 0 to pi by 2. So we know the reduction formula is m minus 1, m minus 3, n minus 1, n minus 3, and in the denominator m plus n minus 2, m plus n minus 4, and so on. Okay. And we have to multiply pi by 2 if both m and n are even, but here both are odd, so we can omit this. So now in this case m is 7 and n is 3. So we have 7 minus 1, 7 minus 3, 7 minus 5, and 7 minus 7 we can't take because that will become 0. That will make the result 0. So now n minus 1, so 3 minus 1, and we can't take 3 minus 3. That will again make the numerator 0. Now the denominator part is 7 plus 3, 10. So 10 minus 10 into 10 minus 2 into 10 minus 4 into 10 minus 6, 10 minus 8, and that's it. So which is equal to 6 into 4 into 2 into 2 by 10 into 8 into 6 into 4 into 2. So for m is equal to 7 and n is equal to 3, we have this as the result, which is 1 by no. Now final result is this. Final result, to get the final result we have to multiply 8 by 3. So if you multiply 8 by 3, you will get final result as 1 by 15. So this is the 1 by 15 is the right answer. Okay. right? Let us go to the next problem. The value of the definite integral root x log x dx is. We know that integral u dv is equal to u into v minus integral v du. Now let us put u as ln x, that will give du as 1 by x dx. Okay, and let us put dv as equal to root x dx. Then this is x 1 by 2 dx. Then v will be equal to integral x1 by 2 dx, which is x 3 by 2 by 3 by 2, that is 2 by 3 x 3 by 2. Okay, so now we have this, and v is equal to this result and this result. Now let us replace the value in the original integral. So ln x into 2 by 3 x 3 by 2 u times v, okay, minus integral v du minus integral v 2 by 3 x 3 by 2 and du, so 1 by x dx. Again, so this is x 3 by 2 minus 1 which is x 1 by 2. So this is 2 by 3 x 3 by 2 ln x minus 2 by 3 x 1 by 2 plus 1 and 1 by 2 plus 1, that is 2 by 3 x raised to the power 3 by 2 ln x minus 2 by 3 x raised to the power 3 by 2 by 3 by 2. Okay, now we have to put the value of limits, so 1 to e, right? So this is this is 4 by 9, okay. So now put 2 by 3 and x as e raised to the power 3 by 2 ln e is 1, so minus 2 by 3 ln 1, that is 0, and then minus 4 by 9 x e raised to the power 3 by 2 and minus 4 by 9. Okay, so this is 2 by 3 e raised to the power 3 by 2 minus 4 by 9 e raised to the power 3 by 2 plus 4 by 9. So this can be simplified as 2 by 9 e raised to the power 3 by 2 plus 4 by 9. Then answer is 2 by 9. So this is the right answer. C is the right answer. Okay. Now let us go to the next problem. The value of the integral 0 to pi x cos square x dx is. Okay, so we can write cos square x as, we know that cos 2x is nothing but 2 cos square x minus 1. Then cos square x can be written as cos 2x plus 1 by 2. So here, so 0 to pi x cos 2x plus 1 by 2. Yes. Now this becomes 0 to pi x by 2 plus x cos 2x by 2 dx. Yes. Again, if you integrate this, so you can separate this. Dx and 0 to pi dx. So this will be equal to x square by 4, 0 to pi, and if you evaluate this, so this is in the u into v form, so taking x as u and v as cos 2x, then u dv will be equal to x sin 2x by 2, taking 1 by 2 out, and then minus integral dx by dx and integral cos 2x dx, then this will be equal to sin 2x by 2, so which will be equal to plus cos 2x by 4. Yes, and varying from 0 to pi. So this is pi square by 4 and plus half. So sin 2 pi is 0. So 0 and plus cos 2 pi is 1 by 4. Cos 2 pi is 1 and this will be 1 by 4. Then minus, again sin 0 is 0. Then cos 0 is 1. So again 1 by 4 plus 1 by 4. So final answer is pi square by 4 plus 1 by 2 and 1 by 4 minus 1 by 4, that is 0. So pi square by 4 is the right answer. Let us go to the next problem. Consider the following definite integral. The value of the integral is. Let us put sin inverse x as t, then dx by root under 1 minus x square will be equal to dt. Now you can write I as t square dt, t square, and this is dt, so dt. Okay. Now, and yes, limits are, so x is varying from 0 to 1. When x is equal to 0, t is equal to 0, and when x is equal to 1, so t is equal to pi by 2. So 0 to pi by 2 t square dt. Then this is t cube by 3, 0 to pi by 2, so which is pi cube by 24. So you will get A as the answer. Okay. Let us go to the next problem. The integral dx by root under 1 minus x 0 to 1 is equal to. Okay. So if you remember, 0 to a fx dx is equal to 0 to a f of a minus x dx. So using this property of integral, definite integral, we can equate this 0 to 1 dx by root under 1 minus x. We can equate this to dx by root under 1 minus of 1 minus x, which is equal to dx by root under x 0 to 1. Again, x power minus 1 by 2 plus 1 by minus 1 by 2 plus 1, which is equal to 2 root under x. And now substituting the limit 0 to 1, so this is 2. So answer is equal to 2 here. Right? Now let us go to the next problem. The value of 0 to infinite 1 by 1 plus x square dx plus 0 to infinite sin x by x dx is. Okay. So if this is in I1 and say this is I2. Okay, right? So 0 to infinite 1 by 1 plus x square dx is direct tan inverse x 0 to infinite. So tan inverse infinite minus tan inverse 0 is pi by 2 minus 0. And for I2, integral 0 to infinite sin x by x dx. Okay. So let us recall Laplace transform of sin x is 1 by s square plus 1, and we know that Laplace transform of fx is equal to 0 to infinite e power minus sx f of x dx. Okay. And since frequency integration f of x by x is, so Laplace transform of f of x by x is equal to 0 to infinite fs dx. Okay. So now we know that Laplace transform of sin x is 1 by s square plus 1, and Laplace transform of sin x by x will be equal to 0 to s to infinite, sorry this is s, so s to infinite f of s ds, and fs is 1 by s square plus 1, so s to infinite 1 by s square plus 1 ds. Now evaluate this. So this is nothing but tan inverse s, and s is varying from s to infinite. So tan inverse infinite minus tan inverse s, so which is equal to pi by 2 minus tan inverse of s. Okay. Now this is nothing but cot inverse of s. Yes. Now put s is equal to 0. We get 0 to infinite sin x by x dx is equal to cot inverse 0, which is equal to pi by 2. So this is an important result. Okay, this one. Right? And then we have the final result as pi by 2 plus pi by 2. Okay, so that is pi. So pi is the right answer. Right? So by this we have completed this session. I will start differential equation in the next lecture. Keep preparing. Thank you.